Welcome back again. We are now dealing with the second part of lesson 9.2 for geometry, and we're delving further into radians and their application. And this time we'll actually get to the sectors part. I just didn't feel like I wanted a 30-minute video on this, so it's 2 15s or a 15 and a 25 or 15 and a 10. Okay. The next kind of problem that they've asked of us. An arc subtends a central angle measuring 3 pi over 2 radians. Well, in the previous video, we showed that that was 270 degrees. Okay, because this is half of a pi, another half of a pi, another half of a pi. Not the entire pi, pi-e, but half of a pi, pi. Don't forget that, the Greek letter. Now, one neat thing about Khan Academy that I like is when they have difficult words or new words that they've entered, they'll boldface or blue them out. And all you really actually have to do is hover your cursor, your little arrow right above that. And I did the screenshot while I was doing that. And it reaches from one way, from one ray to the other. Okay. An arc reaches from one ray to the other of a central angle measuring. So this ray, and basically what they're saying is that their rays go on forever. That might be the straightest line I've ever drawn on here. That was not an actual line function. That was just a legit straight line. And it goes to the other ray, and I'm scared to do the other ray because I don't want it to not be straight. Oh, I finished a little off skew, off center. Off skew would be straight, wouldn't it? Anyway, so it goes from here, and it's going in this direction. The big angle, the major arc. Many times you'll actually see it. Okay, a major arc with a central angle measuring 3 pi over 2 radians. What fraction of the circumference is this arc? Okay, of. What fraction of? That's one thing we need to remember. Now, this is the fraction that they gave us. Okay, this is the of what? The entire circle, 2 pi. Don't forget it's 2 pi over 1, and when we divide fractions, we flip it over and we multiply. So this goes away. I flipped it over and we multiply it. Now the pi's cancel out. And I've got 3 times 1, which gives us 3, 2 times 2, which gives us 4. Now some people still that's a little fuzzy for them. Well, let's look at the fraction of it is. We know that that's 90 degrees, that's 180, and that would be 270. So what I'm going to do after I delete that, I'm going to, put that down there, 270 out of a possible 360. Now we're going to divide by 10 to get rid of that. And then what I end up with is 26 or 27 over 36, which both are divisible by 9. Again, I'm going to hint with that. 2 plus 7 is 9, so it's divisible by 9. 3 plus 6 is 9, so it's divisible by 9. I divide both of those by 9. And I get 3/4. Same as if I had done it with the radians. Okay, my watch is buzzing like crazy, so I'm getting lots of text messages. So I'm going to focus here. I need the blinders, Now, what is the length of arc S shown? Enter an exact expression, so you're not going to use decimals. And I love that. Okay, this is pi over 4, which we remember from the unit circle intro is pi over 4, 45 degrees. Okay, 45 degrees. Well, 45 degrees is 1/8 of the circle. Now, if we do it this way, the fraction is pi over 4 over a whole circle. Flip it over, the pi's disappear, and I get 1 over 4 times 2, which is 8. Now it's 1/8 of the circle. They've also given us the radius of 2 centimeters. So the whole circumference would be that 1/8 times 2 times the radius, pi, or the diameter, which would be 4 times pi. Well, this cancels here, the red one. Red cancels, that leaves me with 4. White cancels with the 4 and leaves me at 2. Okay, now that is, don't forget of is multiply. That's what I've got that for. So we've got 1 pi, or pi, over 2. Oops, there it is. Get out of there. And there we go. Pi over 2 is our answer. Pi over 2 is our answer. That seems weird. I get that that seems weird. Well, wait a minute. You've been talking about pi over 2 is 90 degrees. Yes, but that is converting from 90 degrees to pi over 2, or to pi over 2 to 90 degrees. This is different because we're doing in length. What is the length? Okay, in terms of pi, pi is the number of radiuses all the way around. Well, 2 pi is. And we've got to do that in terms of that length. And so it's only half of a pi in distance. Don't confuse those two. I know it can happen. I know it can happen. They are different. It's difficult because a 60-degree angle, as we did before, might have 1 unit. Whereas this pi over 4 has pi over 2 units. And those seem like the same thing we were already using. Okay? It will clean up as you get older, especially in pre-calculus. What is the measure in radians of a central angle, theta, in the circle below? They've already given you the arc length, 5. We've been given the radius, 2. I wonder if I actually have that there. Oh, I do. Good. Look at that. Okay. We have the radius is 2. We know that theta would be divided by 2 pi. Okay. Well, I see that, and there's all these things. This 2 can cancel. This pi can cancel. So I'm going to be left with 2 theta is equal to pi. And look at that, or is equal to 5. 2 theta is equal to 5. So therefore, if I divide both sides, and I just bring this guy over here, theta is actually 5 halves. 5 halves. Way easy. Haven't needed a calculator for any of this. And that's the beauty of it. If you do this and you learn your fractions backwards and forwards, you don't have to use a calculator. It saves you time. I don't have to pull this out. I don't have to turn it on. I got to make sure if it's solar that it's actually, hitting the lights right. If my batteries are charged, I don't have to reset I just do the math. 5 halves. I don't want you to take an extra step and go 2.5. It doesn't do anybody any good. All right, so write a formula for r in terms of theta. Now we're dealing with 2 variables here for the following figure. Now, arc length. We've been dealing with the central angle, whatever they're giving us, radians or otherwise, divided by 2 pi. Okay? Because that's a fraction of the whole circumference. Then we times it by the actual circumference equation, which is 2 times the radius. Okay? Oh, that's what happened. I'm like, where did the r go? Let's see if I can get it to move. Oh, let's do this. There we go. Move the whole thing. Yeah. 2 times the radius times pi. Okay. If we wanted to do it in in degrees, it would be the same thing. Instead of 2 pi, we just switch it with 360. It's the same deal. Now, in this one, since they've given us that it's 7 pi, and we solve and we simplify all of that stuff, what I'm going to do is I would take this 7 pi up here, 7 pi, multiply, well, cancel out here, those 2, and then divide by the central angle. Because the beauty is, let's use the colors I've got, that 2 pi, whoa, I'm trying to draw here. This 2 pi cancels with that 2 pi. And I'm left with the central angle times the radius is equal to the arc length, which really, if I just divide by the central angle, I have the arc length divided by that central angle measure. I'm just going to put central. It's not really that easy to draw and make it look beautiful on here, and so forgive me. That central angle measure, which is 7 pi divided by theta in this case. 7 pi divided by theta. And we'll use that in some of these other ones as we get to it. Now, area of a sector. We've been doing arc length, the fraction of the circle, okay, that is pi times the diameter for that distance. We now have a new equation because the area of the sector is going to be that same fraction, but now times a new equation, the radius squared pi. Okay? And you've heard it said 100 times, pi r squared, pi r squared, pi r squared. I don't like that because then you put pi first. And we're always taught that our format for writing this kind of thing is to have pi written last. So let's do radius squared pi, radius squared pi, radius squared pi. Okay? And if I do that with these measurements, then what I'm going to get is, whoops, that's not what I'm going to get. I'm going to get that. Okay? So I have, I've got the area of the sector, 11 pi over 2. I've got theta, which is what we're trying to find out. Okay, what's the central angle? Theta divided by 2 pi. Now I've got my radius, which they gave us as 3 squared times pi. Now, the reason these 2's are here is because I noticed that there was a 2 in both denominators, so I multiplied both sides by 2 to get rid of the denominators, because that's what bothers most people. I also am able to cancel these pi's, but now we got to clean it up. Okay, so I'm going to have 11 theta over here. I'm sorry, 11 pi. I'm going to have theta over here, and 9, because it's 9 theta, that's all that's left. I've got 11 pi, that's all that's left. Now, to get theta all by itself, I just divide by 9, and I end up with 11 pi over 9. If I want the degree measure, because it says in degrees, then I replace the pi with 180. I simplify it. That I left the 0 here because it's going to be 20. Okay, I'm really just canceling the 9's there. So 11 times 20, and that gives us 220 over 1, which is just 220. 220 degrees. Now, this looks like it's bigger than 180. 220 is bigger than 180, so it seems like that would be a viable option. Now, we've got 2 more of these to go, and then we'll be done with that. A sector with a radius of 15 centimeters. Radius 15 centimeters. Central angle, 8 pi over 5. Okay, central angle over 2 pi, radius squared pi. We take the fraction of the area equation. Simple. The fraction, talk your way through it. Okay, what do I need? I need a fraction of the area. I need a fraction of the area. So what's the fraction? That angle over the entire circle, and this is the area of the entire circle. So we'll multiply. Now, this one right here should go away. Yep. Okay. So what I've got here is I've got 8 pi over 5. That's the central angle. Divided by 2 pi, we flip and multiply, which causes the pi's to cancel. The 8 and the 2 cancel to give us a 4 over a 1. The radius told us there was 15, so we put that in there. Okay, now we got to clean stuff up again. Okay, still have the 4. I've got the 5. I've got 15 squared, which is 225. I've got my pi. Well, 5 goes into 225 45 times. Cancels. Goes in there once. 4 times 45 is 180. And then I've got my pi. So what is the, what are we looking for? What's the area of the sector? That angle measure is 8 pi over 5, but the area is 180 pi. That's the nice thing about radians, is you keep everything in the same genre. We're not going from degrees to inches squared. We're going from radians, or we start radians, to radians, and this is area, so it would be units squared. Units, whoops, get it right. Units, whoops, that didn't come out right. Squared. Okay, units squared. Units, I didn't have room to put the S. Okay, so we got to remember that all we're doing is radians for angle measure and radians for area measure. It actually becomes a little bit easier for you as the more that you do this. Final one. Okay, area, they've given us already the area. So instead of the area of the sector, I'm going to be able to put 54 pi centimeters squared. Okay, we've got the radius. So what we're trying to find is the central angle. What is the central angle? In radians. So the first thing we do is we set everything up, plug everything in, make sure I hit the arrow button. There we go. Okay, so 54 pi, I got nothing there. I got 2 pi there. My radius is 9, so I put it in there. Everything's written down. Again with the fraction. Multiply both sides by 2. Okay, these pi's cancel out. These 2's cancel out. So I'm left here with 81 and theta, and this is 104 and pi. Okay, so let me do the next one. I'm sorry, 108 pi. So 108 pi and 81 theta, divide by 81, divide by 81. Okay, now these simplify. Again, 1 plus 0 plus 8 is 9. 8 plus 1 is 9, so they're divisible by 9. If I divide that by 9, I get 12. If I divide this by 9, I get 9. It also can be simplified. Just because you've done it once doesn't mean you're done. This has a 3. Divide it by 3, I get a 4. Divide that by 3, I get a 3. Okay, the 81's already gone. So I've got my 4, I've got my pi, and I've got my 3. 4 pi over 3 is that central angle. Whoops. Where is that? Oh, there it is. Okay. Now, if I wanted to change that, I wonder if I did any of that. If that's there, nope, doesn't seem like it is. So I just take this, I multiply by 180 to find the actual degree measure. They asked for it in radians, so I don't have to go that far. But if it does ask for degrees, don't forget it is 4 times 180 over 3. Okay. 3 goes into 18 and 6. That becomes a 1. And this becomes a, I'm sorry, 18 and 3. It goes in there 6 times. Okay. So this is really 4 times 60. I did 4 times 6, but I kept the 0. It's how my brain works sometimes. Forgive me. Really, 3 goes in here 60 times, and then 1, 4 times 60, 240. Okay? All right. And that's it for that one. So again, it's really no different than what you've been doing. Hopefully that helps clear things up, though.